In this lesson, we will examine some important properties of fractions. The first property involves splitting products in the numerator and denominator. So as you can see from the rule, if we have products in the numerator and denominator, we can rewrite the fraction as the product of other fractions. This can often make our calculations much easier. For example, it would take a long time to evaluate this fraction if we had to first find the product in the numerator and then find the product in the denominator. However, when we apply the rule, we can break the fraction into the product of smaller fractions. From here, we can see that 6 over 6 equals 1, 15 over 3 equals 5, and 24 over 4 equals 6. From here, 1 times 5 times 6 equals 30. Also note that we can rearrange the terms in the two products so that the resulting fractions make for faster calculations. When we simplify these fractions, we get the product of 4, 3, and 1, which is 12. Now we can also apply the same property to simplify algebraic expressions. Now in the past, you may have heard people say that we can take a fraction like this one and simply cross out the 22's in the numerator and denominator to get a simplified fraction, 3y plus 5 over 8. What's really happening here is that we are applying the above rule to rewrite the fraction as the product of two fractions. And from here we can recognize that since 22 over 22 simplifies to be 1, the 22's essentially disappear, leaving us with the simplified fraction 3y plus 5 over 8. Now please note that in order to apply the rule here, we need to have products in the numerator and denominator. The rule does not apply to addition. If there are sums in the numerator and denominator, we cannot split the fraction into the sum of smaller fractions. For example, this fraction is not equal to the sum of these three fractions. Notice that the left-hand side here simplifies to be 6 over 6, or 1, and the right-hand side simplifies to be 1 plus 1 plus 1, which is 3. Now there is, however, a property that does allow us to split a certain kind of sum. It looks like this. Notice that we are splitting the numerator into two parts, but the denominator stays the same. So, for example, we can take this fraction and rewrite it as the sum of these two fractions. This property also works with subtraction, so this fraction can be rewritten as follows. Now, the important point to recognize here is that we are splitting the numerator, but we are not splitting the denominator. A common mistake is to assume that a similar rule applies to splitting the denominator. This is not the case. We cannot split sums and differences in the denominator. To illustrate this, notice that 1 over 2 plus 2 is not equal to 1/2 plus 1/2. When we evaluate the left-hand side, we get 1/4, and when we evaluate the right-hand side, we get 1. So clearly this rule does not work. So it's okay to split the numerator, but it is not okay to split the denominator. Notice that the following rule adheres to this. Here we are splitting the numerator, but the denominator remains the same. So, for example, we can rewrite this fraction as follows, and when we evaluate the left-hand side, we can see that it is equal to the right-hand side. Alright, the next property is related to multiplication. It says, if we take a fraction and multiply it by its denominator, the result is the numerator. So, for example, 3/4 times 4 is equal to 3. We can also apply this rule to help us solve equations. Here, if we multiply both sides by 7, we get 2x on the left-hand side, and we get 70 on the right-hand side. From here, we can divide both sides by 2 to see that x is equal to 35. We can also use this rule to simplify strange fractions, such as this one. Since the fractions in the numerator and denominator both have 7 as their denominator, let's see what happens when we multiply top and bottom by 7. First, 3/7 times 7 is equal to 3. And next, 5/7 times 7 is equal to 5. So our fraction simplifies to be 3/5. Alright, our last property looks like this. If some fraction, a over b, is equal to another fraction, c over d, then it must be true that a times d is equal to b times c. We can use this rule to help us solve equations where we have one fraction equal to another fraction. When we apply this rule, we see that 5 times 2x must be equal to 11 times 3. At this point, we can simplify both sides and then divide both sides by 10 to get x equals 3.3. Alright, let's summarize. In this lesson, we learned several important properties related to fractions.